Welcome back, guys. It's a pleasure to introduce our next speaker, Elisa Torres Durney. So, Elisa is the founder and CEO on Gears in Quantum, a global initiative working to expand access to quantum computing and emerging technologies for gears and underrepresented communities around the world. Through her leadership, the organization has already reached thousands of students across more than 60 countries. Her work and intersection of technology, education, and social impact has earned her recognition such as Forbes 30 on the 30 and the Quantum 100. And she's actively collaborated with international institutions like UNESCO to promote inclusive innovation. Alisa, thank you for joining us today. This stage is yours.
Thank you so much, Braulio. I really appreciate it, and I'm very thankful to be able to share this with you, everyone. I'm very excited about first sharing about our love for quantum computing, but also the work that we've been doing at Girls in Quantum. So it's once again a pleasure. And I'll share my screen right now. So if everyone can just let me know if you can see it, then that'll be perfect. So let's see. We're here. There's a lot to see, so let's start. Share. And then here, can you see this?
Yes, perfect. We can see your screen.
Awesome. Okay, so wonderful. So I want to share more about what we've been doing, especially because we are empowering the world and the next leaders of quantum. And we love that. I started in 2022 with this idea with Girls in Quantum. In 2021, I had the opportunity to learn about quantum computing through an online course. So exactly as we are right now, I was learning about quantum computing. I had no idea what it was, but I was really curious about its applications, but also how I, as a student, could be involved. So that was one part. And through the whole program, I was just fascinated by the science behind it, but also that it had multiple areas of applications, whether it's pharmaceutical sciences, technology, or optimization and logistics. So those areas really fascinated me, and this is an area that I want to pursue. So that's how everything is started. In 2022, when the program finished, I said to myself, why not creating a program that would be for everyone, for students, for people that have no idea about it, but that can also create a wonderful community for them to explore and have fun and also collaborate in this field. So yeah, this is more about Girls in Quantum. We've been doing a lot of programs since then, workshops, seminars, trying to understand how quantum can be communicated in a very nicer way to students and that people that perhaps have introductory background to it. Here's some events where we've done with other inspiring women or ambassador in Germany that has been presenting in different conferences, and our ambassador in Pakistan as well, presenting to policymakers. So there's different occasions we've been able to share about our love to quantum, and not just educational wise, but also in terms of policy, in terms of what can we do now and how to inspire other institutions. What I want to say, and I hope that this resonates to everyone also by the end of the presentation, is that quantum is for everyone. And why do I say this? Usually when I go and share about my love for quantum, there's three main outlooks of this. One, you have to be a genius. Second of all, you need to have a PhD. And third, it's just physics. So let me debunk all those myths. Of course, getting to know more about STEM fields before heading into quantum computing, that would be helpful, 100%, but it's not strictly necessary. You don't need a PhD, you don't need to be a genius, or so on. The best thing is that you have all the motivation and right mindset to keep learning about a new field, but also that it's a field that it's very continuing to build itself and so on. So that's the main thing. We've been teaching to students that are sometimes in middle school, just sharing this with other people around the world. This was in New York Times Square, and then also going to high schools and creating research programs where people have, once again, no background on this, but they decided this is my time. I would love to be involved and learn from applications. So if you say to yourself right now, oh, I don't know about physics, I don't know about quantum, let that don't something that would not matter, but instead be something that you can take as an opportunity to learn and engage. From student to students, this organization, I started it and I said to myself, we have to make it work with other students. Let's inspire together the next generation. And this is all the team that has been working with me, from students that are in high school, middle schoolers, people that are 11 years old, and so old. The main thing is that we can all share with each other our passion, but also be able to create new programs. I remember when Rohini told me about the idea of quantum breakfast, and we were able to communicate with other institutions in her region and organize this program, and so on. We've been organizing also different programs with in Canada, in the University of Waterloo and Perimeter Institute, where we share resources, first of all, but we also create programs for students to learn and engage. So learning about research, spending time with their mentors, and just having as much fun as possible. I think overall, if I want to give you a wider or broader context of this, is that a lot of things are happening. This, for example, was just a couple years ago in 2023, where just these countries were highlighted in terms of what the impact was with quantum. Now, imagine everything purple. Right now, there's multiple strategies all around the world. There's more than 28 right now, where countries are implementing strategies to first foster the ecosystem of quantum by creating new infrastructure, by talking with policymakers, by creating new educational initiatives. So it's wonderful to see how this are creating like a whole ecosystem where quantum is not longer an academia thing, but is also being sort of shared within people that can take really important decisions. So that's amazing. Many things and many companies are being involved right now, from QERA, QNext, the national strategy in the United States. There was also investment for energy. So you can see here how like the different applications are being taken here, and that it's not just one area that people are working on. There's also cybersecurity, which is a main topic, and not just in the United States, but also in other countries where national security is a very important aspect. Let's see, how can I? Perfect. So here are some applications I love for you to discover more, and I would highly encourage you to look at the IBM website, for example, and explore the current applications of quantum computing. There's from electrical vehicles and Mercedes-Benz and their goal to be carbon neutral by 2030, to also understanding more about the logistics, marine logistics, and how to be more efficient in terms of all the gas that is needed, and the petrol as well for maritime logistics. So it's very interesting in terms of also the semiconductor industry and how right now has been very in every headline possible. So I would highly encourage you to look further at these examples and see how it's being applied. There's also multiple companies. This is ExxonMobil, for example, Mercedes-Benz, GSR, Mitsubishi, and more. But I would highly encourage you because there's some applications that you perhaps never thought would be possible. So yeah, once again, quantum and the future. I think that for us at Girls in Quantum and for everyone that will be able to continue in this field, the main concerns or the main areas of focus would be priority in research areas. So I would love to see more experts working in this field, but also be able to share this niche area, so to say, with other scientists that do not perhaps work in the same institution, but they work also in other countries. And that is specifically important because a lot of advancement and progress is being done in different universities. However, if that knowledge is not communicated to others or translated, or there's a collaboration, then unfortunately progress is much slower, right? One of the main areas for us is human capital and talent. Right now, if we talk about one of the hot topics, AI, there's a lot of things happening. There's from ethical concerns, what is happening in terms of government, and also how we're applying it as people that work every day with different aspects and that might use AI or artificial intelligence in different ways. And for us, one of the main things is that before we get to a level where quantum is very accessible to everyone, we have to first train all people and be able to give them the right tools for them to use and communicate their talents. So whether it's understanding Qiskit, which is a platform that you can use to run on quantum computers, to understand more about the tools that you'll need and prepare you for all the other things that will come in the future, such as ethical concerns as well. So that's where we work on. And also, in terms of research and development, again, having this infrastructure and the ecosystem that can foster what scientists are working on. And later on, we have industry and supply chain and market opportunities and adoption. So I would highly emphasize this one as well, because if we have different opportunities for commercialization, I think it's very important that we understand how can it be adopted in different industries and how can we communicate a product that is being developed, for example, in a lab or in the ecosystem of a university, for example, and being translated to someone that can sell that product and explore different market opportunities. So it's very interesting. And as I said before, there's opportunities in machine learning, chemistry, finance, and so on. And one of the main things that we have to take into consideration is that even though we haven't had or reached a level where everything will be available as a commercial product, as let's say a pencil that will be sold to you, instead it's something that will be more adequate for certain problems. It won't replace classical computing, so it will replace our phones or laptops and so on. But there are applications that will be specific for problems and that we might be able to use in the future. So that's very interesting, and I would also encourage you to take a look at it. Next. Let's see, next one. So some of our projects, we've been able to develop lots of projects that are regarding to technology, to empowering other students, but also to provide them with knowledge. We created a data science and quantum computing course with Levagon, and that was pretty interesting because we went to high schools and we were able to see how students understood the technology, but also combine it with the data science aspect, with programming, coding, and how can that be related to quantum computing. So that's pretty interesting. From also quantum conversations, one of the main things is that I'm not sure how is it for everyone here, but one of our main concerns at Girls in Quantum or priorities is that we can inspire the next generation through other people. So we share with them role models, which is great because they share their stories of non-conventional unconventional paths where people start sometimes in history and end up in quantum computing. Somehow people change their paths and align to quantum computing afterwards. They learn it from a course, from a mentor, and so on. And we want to share those stories to others, to say that nothing is a specific path, but you can get to this field and be involved, equally as involved as other people that have been in the field. So yeah, we've organized one of the largest quantum computing hackathons with Qiskit as well in Latin America and Heidelberg University, a research program that I was telling you before, where we had a lot of mentors and students gathering there. Also a quantum computing game with a Swiss researcher. It's the name of the game is called HOP. And the wonderful part about it is that we can communicate quantum mechanics, understand superposition, entanglement, interference, and other properties of quantum mechanics in a much easier way and by playing cards. So that's very nice. And we also had this quantum geopolitics book, which was created by one of our ambassadors, Dia from the UK. So that's very lovely. And yeah, I want to show you this video specifically because it's from Mercedes-Benz and how they're working with quantum. So hopefully you can see it. Let me know if this is possible. Can you listen to it, or is it not good? Yes.
We can hear the video. Okay, you can run it.
Okay, I'll put it again, but was I able to,
Okay.
were you able to listen? Yeah, can you listen a little bit?
No.
No?
Yeah, we can listen.
Okay, perfect.
Yeah, we can listen. Yeah.
Okay, wonderful. Let's start. Right.
Mercedes-Benz has been moving people and goods around the planet for over 130 years now. Every day we ask ourselves, how can we bring...
Oops. Uh-oh. Well, this is usually for technical issues, but now
Mercedes-Benz has been moving people and goods around the planet for over 130 years now. Every day we ask ourselves, how can we bring the future into reality? This is at the heart of who we are, and this can only be achieved by continuously innovating. Right now, our industry is in a transition to a new age. It's time to reduce our impact on the planet. Our goal is for the entire Mercedes-Benz vehicle fleet to be carbon neutral by 2039. That means implementing electric driving in all divisions as a priority. For that, we need to focus on next generation battery technology.
The thing that has always held battery technology back, and this will sound strange, is that we don't really know what goes on inside of batteries. This thing is a mystery. Sure, we know how to make batteries, but we can't actually see what's happening at a molecular level inside the battery while it's working. A battery is more like a complex ecosystem than a machine that spits out electricity. It's chaos in there. And to make things even harder, there isn't a supercomputer on the planet right now that could accurately simulate what's going on in there either. Simulating this at the molecular level of detail involves accounting for a tremendous number of electron interactions, each electron influencing the other in complex ways. Accurately simulating electron interactions in the simplest molecules takes many days on the most powerful supercomputers on the planet. And as for the reactions in a battery, forget it. So what we have to do is approximate the chemical reactions in a battery using classical algorithms. They're not very good and average out a lot of reactions and make a lot of assumptions, but they're all we have. So designing more efficient batteries is a laborious process of trial and error that takes decades.
Mercedes-Benz has turned to IBM Quantum to explore how we can simulate the chemical reactions in batteries more accurately. IBM Quantum computers are built with quantum mechanical systems at their heart. They are designed to simulate quantum systems such as chemical reactions far more efficiently than classical supercomputers. With these simulations, we're exploring new materials to create more efficient batteries. At Mercedes-Benz, we continue to advance our development of current and future high-performance lithium-ion batteries, but also have a close look at what's beyond lithium-ion. We strive to explore cutting-edge technologies for our customers in support of the high-volume electrification for our entire model portfolio.
Today, IBM already has over 20 quantum computers running across the world, running over 1 billion executions a day on the IBM cloud. We've opened this technology up so everyone can sign up and experiment with it. So far, that means over 300,000 users.
Perfect. So I want to just share that. Oh, there it is. To share that because I think it's very interesting to see how this is being communicated to the outside world. There's like so many applications once again in terms of quantum computing and in this case with Mercedes-Benz, how they're working with their batteries. So it's very interesting and there's so many other applications to explore. So just as it's happening right now with them, there's other companies being involved. So I would highly encourage you once again to take a look at those examples and have fun and see if something really, really stands out for you. And yeah, here's more of our programs. Remember the quantum conversations I told you. Here are more students that have been interviewing other leaders in the field, from Carla Herrmann, a leader in Chile, also Franziska Greiner, also in terms of her experience in quantum computing, interviewing people from Amazon Web Services and so on. This is the book that we have, the scientists which we collaborated for the game with cards in our program for research as well. That's been very interesting. Here's a little bit I want to show you really quick of our video with the let's see, our video from we had a video with LeVar Burton from this is a little bit that we had, where we shared about quantum computing. But the main thing was that we had different people sharing their perspectives, so that was really fun. It was him as the start of Star Trek, for example, but he was the narrator, and we had people from IBM, we had people from also different institutions that were sharing about their research that I really wanted to share with you.
Quantum is the study of small systems, such as electrons and atoms, which behave differently than we as human beings do.
We manipulate these tiny particles to make some really cool things happen.
Information science, of course, gave rise to the computer and the internet, and quantum mechanics tells us about the theoretical physics of nature, drugs, new materials.
I'm also betting that quantum science and quantum sensors will be the backbone for medical imaging.
More applications there.
Much more detailed analyses and diagnostics and still be non-invasive, which is exactly the kind of tool we're going to need when we do go to deep space as human beings.
When I say to people that I'm running an organization in quantum computing, they look at me and say, quantum computing, what is that? It's definitely something really motivating and encouraging for me and other students to start learning about these emerging technologies and discovering all the things that are going on right now.
Quantum science happens in a lot of places. Scientists and engineers are using quantum technology to reveal the unknown and to explore new frontiers in some surprising locations.
Just around the corner from me is an incredible quantum science lab called the Cold Atom Lab that has been doing some amazing physics for the last 5 years, and it just keeps getting cooler and cooler every day. NASA right now is in partnership to develop a quantum sensor satellite to map the Earth's magnetic field because it's dynamic and very complex. And a sensor like this would actually probe the substructure beneath the surface of the Earth and also reflect things like the effects of melting of glaciers.
You see, there's more applications coming up and more applications that can be shown to you. So it's pretty amazing. And I love partnering with other people and having these partnerships with them that can communicate science and that can make it fun and accessible and that can show everything to you. So there's from pictures to videos to people working in their labs, in the spatial units there. So I think it's very amazing, and I'm just every time I'm very, very in awe of what's happening there. So yeah, we had coming up, we had like this wonderful research that we had with other institutions. We had and I think that overall, what we expect for the future is like this cross collaboration, having more internships in a learning environment. Of course, also having entrepreneurship within quantum, because it might be seen as something that is very encapsulated into physics or academia, but we want to show that it's much more. And there's entrepreneurs out there that are already working with quantum. There's incubators, accelerators, and so on. So don't be limited by what you might hear, but instead look at different examples of people leading in this way and in different areas as well. So yeah, I think that overall what companies can do in the future, and I hope that that is something that happens, is that they can product test different things and see how they work, have mentoring and training for their collaborators, and see that they can be prepared for the future and for what's coming. And lastly, seek for talent and diversity, and that's what we're focusing on at Girls in Quantum. So yeah, I would say that quantum is now one of the main things for us is to be able to be accessible to democratize quantum computing education and be able to have so much fun. And I hope you have enjoyed this presentation, and now I'm open to any questions.
Thank you, Elisa. We have some questions for the public. We'll start to read one for Sebastian. There is a specific moment in your career when you realized the importance of creating more inclusive pathways into quantum technologies?
Yeah, for sure. I think that there were definitely a lot of moments where I found myself with, am I the only one here? Or I want to see more people like me. Because I saw a lot of adults and people that had a lot of years in the industry. So I said, well, where's the young people? Where are more girls? Where are more students? And one of the main things for me was just joining different conferences where it was very clear that there was a pattern of people that would go to these conferences, and I was like one of the only people there, only girls there. So I decided that that was one of the moments that made me realize that I could do something for it, that I can create a community that it's as welcoming as I want, that can also have all the opportunities for other people to learn and engage, and that can reach out to mentors for help for different materials from other organizations and so on. So those conferences and other experiences where I joined different online programs made me realize that I could also be part of this, of the solution, and be able to create a community that is as enjoyable as I want.
Beautiful answer. We had another questions. So what are some of the most inspiring stories you have seen from the students participating in Gears in Quantum programs?
Oh, this is a tough one. One of the most beautiful stories I would say is when students get to join the Girls in Quantum community. They join Discord, and they literally get so engaged into this, and they tell me, "Wow, I've never been so fascinated by this. I became friends with people in the team." I remember Tambi was one of the girls that joined last year, and she's 11 years old, and she was telling us, "I love quantum computing, I love quantum mechanics. I have this book that my dad gave to me, and now through Girls in Quantum, she's been able to share her voice in different conferences." And I just feel like an old sister to her, because it's very beautiful to see how students get involved in this and they engage with the community, but also they see that there is much more than they perhaps never thought about. So that's wonderful. And I think the second thing is when I see impact in local communities, so people going in their high schools and be able to present about Girls in Quantum, about their love for quantum computing, engage with professors, or sometimes when we had a student that was very inspired by other mentor, and we did everything possible to contact her mentor, and he was able to interview her and have an amazing interview together. So those moments really make the difference, and I love when people have these ideas in mind, they work for it, and it happens because it shows persistence and resilience.
Thank you for that answer. We had another questions. So, as a woman leading an international organization in a high technical field, what challenges have you faced, and how do you overcome it?
For sure. For us, the main challenges has been our age sometimes. When I started, I was 15, 16 years old, and I remember emailing tons of people, and they would be really willing to help to know more about the organization. However, when I would jump into a meeting, they would see a baby face instead of someone that they thought perhaps would be an adult, or it would be more serious organization and so on. And that was one of the challenges, because we couldn't create any other partnerships or establish different initiatives that we wanted or that we had in mind because of that reason. But we didn't take that as a limiting barrier. We took it as an opportunity, that saying to ourselves, okay, perhaps there's not many organizations that are run by students. Let's make this a thing. Let's share this with others and empower other students through this reason, through this, I would say, factor. And that was amazing. But I think other factors and limiting challenges is there's lots of different ways to communicate science. And for us, having the right support is super, super important. So if we don't have the right tools to communicate about quantum mechanics, then it comes to sort of like a different way to explain it. It's very difficult. So getting access to mentors and professors that can be really of use for us to communicate science in the proper way has been a challenge, but it's been very useful as well.
I think so we are almost on time, but we had more questions. So if you
Perfect.
could send one message to young girls around the world who are curious about science and technology, what would it be?
For sure. One of the main things for me through Girls in Quantum is learning the awesome community that is out there. Once again, I started when I was 15 years old. I engaged with this huge community, and it was fascinating to me. And now reaching 8,000 students from 60 countries, it's I would say a win scenario from all the team and all the members. So put yourself in those scenarios that challenge yourself, that can make you feel that you're in a community, that you can engage with others, learn from role models. That's my main goal, that you can put yourself out there and be always willing to learn and have that feedback, because sometimes they might be different challenges, 100%. But the main thing is that you're willing to learn and receive all those comments and be able to grow and just engage with all the other people. So yeah, that's my takeaways, and I hope that everyone can enjoy. I know that Hannah will present later on, so all the best to her, and I hope that you can all enjoy this wonderful event.
Thank you so much, Elisa.
Thank you, Braulio.
Thank you for the beautiful presentation and being here for us today as the guest speakers. We truly appreciate you accepting our invitation and share your experience with our community. And we hope to see you in the future events. Collaborate together.
Yeah, see you. Bye.
Bye.